los conceptos y criterios necesarios para diferenciar textos nocivos de los que no lo son, para identificar lo que es apología del delito y la violencia, textos que alaban, justifican o defienden situaciones de agresión, así como la detección de ciertas características como el uso de interjecciones de risa o emoticones, signos que pueden cambiar el sentido de un texto que parece incitador y convertirlo solo en una broma.
Lo que está haciendo el equipo de trabajo en este momento es analizar estos comentarios para desechar aquellos que, a pesar de que puedan tener ciertas características, y por características me refiero, por ejemplo, a palabras o frases que aparecen en ellos, al final puedan no considerarse como comentarios apológicos. Entonces, este equipo básicamente separa lo que son comentarios apológicos y comentarios que no lo son.
Como parte del proceso, el Dr. Castro y la ingeniera Álvarez desarrollaron fórmulas matemáticas que ayudan a analizar los mensajes y a descubrir las palabras clave previamente seleccionadas. Ellos han identificado que algunas conductas agresivas o formas de violencia física o psicológica son fomentadas no solo en el contenido, sino también en la manera en que están escritos ciertos mensajes.
Bueno, ahorita nos encontramos ya en la fase del desarrollo de los modelos. Primero se realizó una extracción de comentarios. Como comentaba el doctor Noé, se llevó a cabo la extracción de pequeñas muestras de comentarios en donde se identificaron ciertas palabras clave. De una vez identificadas ciertas palabras clave como puede ser muerte, matemos, secuestrar, o sea, palabras que sabemos que tienen una carga se puede decir emocional más que nada, que va relacionada con algún delito o con alguna una invitación a la comunidad a que lo cometan.
En este 2020 se pretende culminar la etapa de diseño de esta aplicación, un proyecto en materia de inteligencia artificial cuya meta es contribuir a prevenir la propagación de la violencia en los distintos sectores poblacionales.
Por encima de estos modelos ya podemos construir aplicaciones que podemos dirigir a ciertos sectores. En particular yo me imagino al padre de familia que está preocupado por sus hijos o sus hijas. Pudiéramos pensar en una aplicación que se puede insertar en un navegador o en el teléfono celular y que filtra estos comentarios que se hacen en la red social. Por otro lado, estoy pensando yo en unidades de atención ciudadana en donde se pueda dar una asesoría técnica a las personas que en un momento dado están siendo agredidas por este tipo de comentarios. Sí, al final estamos construyendo modelos que nos permitan identificar comentarios con ciertas características. Podemos crear un modelo que me identifique todas las clases o podemos crear diferentes modelos enfocados a diferentes tipos de comentarios.
La tecnología y la investigación siguen sumando grandes avances que conoceremos en nuestro próximo Enlace con la Ciencia.
Hoy en día la movilidad en calles y avenidas ha ido en aumento debido al crecimiento desmedido de la mancha urbana, vías de comunicación que resultan insuficientes para el flujo vehicular, tanto particular como del transporte público, y que además de generar estrés, provoca un índice alto de contaminación.
Si lo que buscamos es un nuevo enfoque, ¿no? Buscamos cómo utilizar toda la información que se genera ya por las ciudades y que ha sido muy desaprovechada, y lo que estamos intentando es cómo crear un lugar único donde almacenar toda esa información. Y por otra parte también estamos desarrollando aplicaciones que puedan utilizar datos, por ejemplo, de dispositivos de Internet de las Cosas o teléfonos celulares para obtener información que tenga que ver con el tráfico, ¿no?
Investigadores del CENIDET en el estado de Morelos han creado una aplicación que permite, además de conocer el tránsito en cierta zona, saber de los índices de contaminación en la ciudad, así como el clima.
El proyecto consiste precisamente en cómo poder obtener datos de todas las posibles fuentes que provee el gobierno, de los datos de contaminación de la ciudad, los datos de movilidad que puedan proveer empresas de manera gratuita, incluso de la movilidad misma que es monitoreada por los usuarios, y poder ponerla toda a disposición en una nube pública, de tal manera que esos datos puedan ser después consumidos por otros desarrolladores para poder generar aplicaciones.
No únicamente facilita la movilidad en las vías de comunicación, sino de comercios y dependencias de gobierno, en donde permite conocer sobre la disponibilidad. Aplicaciones con las que se busca la creación de ciudades inteligentes.
Estamos tratando de desarrollar aplicaciones que ayuden a construir ciudades inteligentes, edificios inteligentes, organizaciones inteligentes, con esas aplicaciones que puedan tomar decisiones de que algo está ocurriendo, de estar monitoreando lo que pasa dentro de un contexto.
Hoy en día la ciencia y la tecnología son clave en la creación de este tipo de herramientas para la ciudadanía. Un proyecto que promueve soluciones en cuanto a la movilidad inteligente y sustentable, pero además preventivo, ya que emite alertas para evitar algún tipo de percance con el apoyo de sensores.
El proyecto de Driving App es una aplicación que fue desarrollada en colaboración con la Unión Europea y lo que hace esta aplicación es detectar conductas erróneas en el manejo de un automóvil.
Se busca generar aplicaciones abiertas al público y que puedan ser reutilizadas, información que se concentra y que está disponible para la población en diversas ciudades, con datos como de la calidad del aire, tráfico en tiempo real, localización del transporte público, además de puntos de interés y alertas ciudadanas, contenedores que almacenan y que solo necesitan ser descargados. Con imágenes de Tomás Serna, en la edición Sergio Cosío, Teresa Flores, Noticieros, Televisa. Es inteligencia artificial la cual se aplica en mujeres víctimas de violencia, una terapia que se da a través de un proyecto que desarrollan especialistas del CENIDET Campus Morelos en conjunto con el Instituto Nacional de Salud Pública.
Lo que estamos haciendo es implementar una técnica psicológica que se utiliza principalmente para combatir los efectos negativos del estrés. Esta técnica psicológica, que lleva como nombre escritura emocional autorreflexiva, básicamente consiste de 4 sesiones en las cuales se les pide a los pacientes que narren una vivencia emocional negativa o un evento estresante.
Una técnica psicológica que ha tenido un efecto positivo tanto en mujeres que han sido violentadas como en diversas situaciones que pudieran provocar algún trastorno mental o sean vulnerables ante alguna situación que se registre en su entorno.
Se busca principalmente que este evento que se va a narrar no se haya comentado previamente. ¿Qué significa esto? Que tenemos gente que mantiene en secreto algún evento estresante y evita pensar en ello. Entonces, lo que se hace en esta técnica son 4 sesiones y en cada una de ellas se les pide a los pacientes que narren este evento de manera escrita. Al final, cada una de las sesiones, por lo tanto, va a derivar en un escrito.
A través de diversas sesiones se da la escritura emocional autorreflexiva, en donde se busca dar tratamiento y apoyo a quien lo requiere por medio de inteligencia artificial, la cual identifica aquellas palabras claves dentro de los textos.
Lo que nosotros estamos haciendo es aplicar un análisis de inteligencia artificial, en particular un área que se denomina procesamiento del lenguaje natural. El objetivo de esta disciplina básicamente es dotar o desarrollar modelos computacionales que simulen o tengan la capacidad de realizar actividades lingüísticas humanas. Lo que nosotros estamos haciendo es atacar 2 objetivos. Por una parte tenemos un objetivo tecnológico, en el cual estamos desarrollando una herramienta a través de la cual se pueda aplicar esta técnica de escritura emocional, y tenemos ya un prototipo montado en la web, lo que significa que podemos acceder a él a través de navegadores, y también tenemos un prototipo que funciona en teléfonos móviles.
Una terapia que busca conocer esas sensaciones, emociones y patrones del pensamiento a través del lenguaje escrito.
Tenemos un objetivo científico, el cual consiste en desarrollar estos modelos o desarrollar algoritmos que permitan analizar lo que las personas están escribiendo. De esta manera, lo que nosotros estamos logrando es identificar, por ejemplo, la transición de un estado emocional negativo a un estado emocional positivo. Por una parte. Por otro lado, también estamos aplicando algoritmos de análisis del discurso, lo que nos va a permitir, por ejemplo, identificar de qué manera las personas están plasmando sus ideas, saber cuál es la fluidez o la claridad con la cual lo están haciendo.
Una herramienta que ya se aplica en el estado de Morelos. La inteligencia artificial imita las funciones cognitivas del humano y hoy en día existen en diferentes aplicaciones. Este proyecto es uno de ellos y lo han desarrollado investigadores mexicanos. Con imágenes de Tomás Serna, en la edición Samantha Beltrán, Teresa Flores, Noticieros Televisa. En el Centro Nacional de Investigación y Desarrollo Tecnológico que se ubica en Morelos, el CENIDET, investigadores y especialistas están creando una plataforma de realidad virtual que busca prevenir el abuso sexual en niños y niñas.
Actualmente estamos desarrollando en colaboración con el Instituto Nacional de Salud Pública un ambiente virtual de aprendizaje. Ese ambiente virtual lo que nos permite es enseñarle a niños de entre 6 y 12 años cuando se presenta una situación de acoso sexual infantil.
A través de diversos sensores y dispositivos se logra obtener la información, la cual se almacena en un software y es estudiada. Se busca identificar las emociones y la intensidad de cada una de ellas en diversos escenarios.
Tenemos tecnología que nos permite, a través de, por ejemplo, la lectura de actividad electroencefalográfica, son gorros que se les ponen a los niños, no son invasivos. Básicamente lo que estamos tratando de medir es qué tanta emoción está percibiendo el niño cuando está siendo partícipe de ese evento, ¿no? Entonces podemos saber si está triste, si está con miedo, si no le está causando ningún evento en el que pudiéramos afectar su parte emocional, y esto pues nos permite también tener una medición para determinar en qué nivel podemos también intensificar la exposición a los niños, ¿no?
De manera dinámica pretenden identificar cualquier anormalidad en el menor y con ello prevenir algún tipo de riesgo que pudiera estarse presentando en su entorno. Una realidad virtual en donde Sophie y Pablo son los personajes y el niño solo será el espectador.
Esta tecnología lo que permite es que el niño sea una especie de espectador. Está dentro de la escena, no es el partícipe, no es el niño que está teniendo el acoso, y ve cómo hay una escena entre un adulto, un niño o una niña, dependiendo del sexo, y se le dan alternativas. Esto para que el niño aprenda a identificar una situación de acoso sexual y tome las mejores decisiones en función de lo que nosotros estamos recomendándole en el entorno.
Se estudia cada detalle y se trabaja con la ayuda de diversos dispositivos, desde sensores que son adaptados en los visores y que permiten el reconocimiento de las manos para que puedan manipular el entorno virtual. En esta plataforma se tendrá desde una casa y una escuela, además de un parque. Cada uno de ellos se presentarán 5 escenarios de acoso sexual. Tecnologías disruptivas que permiten al usuario meterlo en diversos escenarios, aplicaciones de impacto social y que ayuden justo a la prevención.
En el escenario básicamente lo que se tiene es una casa. En la casa pues hay escenas en una habitación, en la sala, en el jardín. Hay diferentes actores, personas mayores, jóvenes, y cada uno tiene un rol dentro del escenario. Entonces lo que procuramos es que el niño pueda identificar eventos que se pueden dar en casa. Se pueden dar en la escuela, se pueden dar en un parque o en algún otro lugar. De hecho, el entorno en su versión final se piensa hacer como un juego. O sea, se le van a dar incentivos al niño, el niño va a estar participando en diferentes escenarios y la idea sería que entonces se fuera a un escenario de juego serio, ¿no? En donde el niño esté motivado y que no sea un entorno que pudiera incluso hasta llegar a ser intimidante, ¿no? Es más así como, pues voy a jugar un rato, pero en el juego estoy aprendiendo, ¿no?
Se estima que en el 2021 este proyecto se concluye y pueda aplicarse en planteles educativos con la intención de detectar y de prevenir. Con imágenes de José Luis Franco, en la edición Gilberto Cruz, Teresa Flores, Noticieros Televisa.
Tus estudios de licenciatura es solo un principio de tu camino profesional. ¿Quieres transformarte en un experto en tu área de conocimiento? El Tecnológico Nacional de México, Campus CENIDET, te ofrece excelencia educativa y de investigación a través de sus maestrías y doctorados en Ciencias de la Computación, con líneas de investigación en Ingeniería de Software, Inteligencia Artificial, Cómputo Inteligente y Sistemas Híbridos Inteligentes, Ciencias Ciencias y la Ingeniería Mecánica, con líneas de investigación en Análisis y Diseño Térmico de Edificaciones y Sistemas Solares Relacionados, Optimización de Sistemas Mecánicos y Biomecatrónica. Ciencias y la Ingeniería Electrónica, con líneas de investigación en Electrónica de Potencia, Control Automático y Energía Renovable y Eficiencia Energética. Nuestros programas cuentan con acreditación en Programa Nacional de Posgrados de Calidad, PNPC, de ICONACYT, impartidos por profesores e investigadores con grados de doctor y reconocimientos en instituciones nacionales e internacionales. Con la oportunidad de obtener beca y realizar intercambios en reconocidas universidades de países como España, Francia, Japón, Suiza, Colombia, China, entre otros. Para más información, visita la página web cenidet.tecnm.mx, convocatoria-posgrado.php. Intégrate al TecNM Cenidet.
Tecnológico Nacional de México. Excelencia en educación tecnológica.
Professor Laporte, I have to make a presentation. So yes. Your screen, your presentation by the moment, please. Okay, thank you.
Bien, buenas tardes. Damos inicio a nuestro coloquio virtual, un espacio de divulgación donde pues invitamos a investigadores de primer nivel para que nos compartan su conocimiento y experiencias en las áreas de ingeniería mecánica, ingeniería electrónica y ciencias de la computación. Estamos transmitiendo en 3 redes sociales, Zoom, Facebook y YouTube. En cada una de estas redes pues tenemos moderadores quienes nos apoyan dando lectura a sus comentarios y preguntas. Así que les solicitamos que cuando hagan uso de estos espacios, pues por favor nos pongan su nombre y su lugar de procedencia para que podamos hacer un trato más personalizado. Y en este sentido es que les pido a los moderadores que nos presentemos para que pues, nuestra audiencia pueda ubicarnos. Bueno, en Zoom, un servidor, doctor Noé Alejandro Castro Sánchez, doctor investigador del Departamento de Ciencias Computacionales. En Facebook, ¿quién nos acompaña?
Hola, buenas tardes. Mi nombre es Néstor Abril Meneses López y los estaré acompañando y apoyando en la red social de Facebook.
Muy bien, muchas gracias, Adriel. Y finalmente en YouTube.
¿Qué tal? Buenas tardes a todos. Mi nombre es José. Yo estaré preguntas a través de YouTube.
Muy bien, muchas gracias, maestro Josué. Bueno, y nuestro moderador principal, doctor Gerardo.
Buenas tardes. Gerardo Guerrero, profesor del Departamento de Ingeniería Electrónica.
Muchas gracias, doctor Gerardo. Bien, la dinámica que vamos a seguir para dar lectura a las preguntas es la siguiente. Vamos a iniciar con Zoom, donde vamos a dar lectura a 3 preguntas. Después continuaremos con Facebook, vamos a dar lectura a 3 preguntas y terminaremos en YouTube. Este ejercicio lo vamos a repetir en 2 ocasiones. Si al término de estas 2 iteraciones aún tenemos pues, comentarios y preguntas por parte de ustedes, pues podemos lanzar una ronda más de preguntas y respuestas. Y bien, pues en esta ocasión tenemos un invitado extranjero y bueno, en ese sentido, pues en atención a él y a las personas que se estén conectando, él viene de Canadá en esta ocasión. Bueno, nuestro invitado en esta ocasión, pues en atención a él y a las personas que se estén conectando de otros países, pues vamos a estar operando entre los idiomas español e inglés. Y bueno, entonces, si me permiten, pues hacemos nuevamente la presentación. En atención a ellos, pues ahora lo vamos a hacer en inglés. We're starting our virtual colloquium, a space for scientific dissemination, where we invite leading researchers to share their knowledge and experience in the areas of mechanical engineering, electrical engineering, and computing science. We are broadcasting in 3 digital platforms, Zoom, Facebook, and YouTube. We have moderators in each in these platforms who help us to read your comments. The dynamic that we're going to follow to read your questions is as follows. We start with 3 questions in Zoom, then we continue with 3 questions in Facebook, and finally 3 questions in YouTube. We will repeat this twice. So, I now give the floor to the main moderator, Dr. Gerardo, please.
Muchas gracias, doctor Noé. Voy a compartir una presentación. Buenos días a todos. Bienvenidos al coloquio virtual. A nombre de nuestra directora, la doctora Jessica Imelda Saavedra Benítez, les damos la más cordial de las bienvenidas. Pati. Perdón, Pati. Bueno.
Welcome to our virtual colloquium. In the name of Jessica Imelda Saavedra Benítez, our head, our director, we welcome you, Doctor.
Nosotros somos el Tecnológico Nacional de México. 254 instituciones distribuidas a lo largo y ancho del país. Somos la institución más grande de Latinoamérica. Atendemos a más de 620,000 estudiantes, alrededor de un 13% de la matrícula a nivel superior y más del 41% de los estudiantes de ingeniería del país.
Okay, we are the largest institution of higher education in Latin America, and enrollment we have an enrollment of more than 626,000 students. We cover more than the 30% of the enrollment of higher education in the country. We cover more than 41% of engineering students of the country. Adelante.
Nosotros estamos en Cuernavaca, Morelos. Somos el Centro Nacional de Investigación y Desarrollo Tecnológico.
We are in Cuernavaca, Morelos, Mexico, and we are the National Center for Research and Technological Development.
Nuestras actividades principales son investigación y docencia.
Okay, our main activities are research and teaching.
Vinculación.
Linkage.
Divulgación científica y tecnológica.
Scientific and technological dissemination.
Nuestros programas de posgrado. Ciencias de la computación con las líneas de investigación, ingeniería de software, inteligencia artificial, cómputo inteligente, sistemas cognitivos.
Okay, our research lines for computer science are software engineering, artificial intelligence, smart computing, and cognitive systems.
En ingeniería electrónica, control automático, electrónica de potencia, energía renovable y eficiencia energética.
Okay, in electronics engineering, our main research lines are automatic control, power electronics, and renewable energy and energy efficiency.
En ingeniería mecánica, optimización de sistemas mecánicos, análisis y diseño térmico de edificaciones y sistemas solares relacionados y biomecatrónica.
In mechanical engineering, our main research lines are optimization of mechanical systems, analysis and thermal design of buildings and related solar systems, and biomechatronics.
En maestría en ciencias de la ingeniería, nuevas tecnologías para el desarrollo sustentable, investigación, desarrollo y aplicaciones de tecnologías inteligentes.
Okay, in our master's in engineering science, we have two lines of research: new technologies for sustainable development and research, development, and application of intelligent technologies.
Los invitamos a hacer un posgrado con nosotros. Ofrecemos calidad académica. Somos 58 profesores investigadores, todos con el grado de doctorado. 46 pertenecen al Sistema Nacional de Investigadores, 7 en el nivel 2. 6 programas de posgrado están reconocidos en el Padrón Nacional de Posgrados de Calidad, PNPC del CONACYT. Tenemos 13 cuerpos académicos, 5 de ellos en el grado de consolidados.
Okay, we welcome you to study your postgraduate degree with us. And we have 48 professors, researchers, all of them with a doctorate degree. 46 belong to the National System of Researchers, 7 in level 2. We have 6 postgraduate programs that belong to the National Postgraduate List of CONACYT. And we have 13 academic bodies.
Como cada semana, en el coloquio virtual viene con nosotros un profesor investigador. En este caso, el turno es del Departamento de Ciencias de la Computación y la conferencia será sobre esta temática.
Okay, as we have been doing, we have a professor, and now is a turn for a scientific dissemination for this talk, and it's a chance for computer science.
Me permito presentar al profesor Claude Laporte. Él ha sido profesor desde el año 2000 en la Escuela Superior de Tecnología, una escuela de ingeniería con alrededor de 11,000 estudiantes, donde él enseña ingeniería de software. Sus intereses y áreas de investigación incluyen la mejora de procesos de software en organizaciones muy pequeñas, también como el aseguramiento de la calidad de software. Él ha trabajado en defensa y en empresas de transporte por más de 20 años. Él recibió un grado de maestro en física de la Universidad de Montreal, un grado de maestro en ciencias aplicadas de la Escuela Politécnica de Montreal y su doctorado de la Universidad de Bretaña Occidental en Francia. Él también tiene un doctorado honoris causa por la Universidad de San Martín de Porres, en Perú, en el 2013. Desde el 2005, él es un editor líder de la serie de estándares y guías de la ISO/IEC 29110, que trata sobre los estándares de ciclos de vida de ingeniería de software y sistemas de software, específicamente para entidades muy pequeñas. También es el copresidente de INCOS, de ingeniería de sistemas para entidades muy pequeñas. Él es miembro ya de por vida de INCOS. También ha sido miembro de asociaciones profesionales de ingenieros de la provincia de Quebec. Él ha escrito algunos libros, es coautor de 2 libros escritos en francés sobre el aseguramiento de la calidad del software, publicada en 2011. Y es un libro de texto con más de 620 páginas. sobre el mismo tópico y publicado por John Wiley e hijos en 2018. Este libro de aseguramiento de la calidad de software ha sido traducido ya al español en 2021 y está siendo traducido al chino. El doctor Laporte es un coautor también de un libro en francés y que también ya ha sido traducido. Este libro está enfocado o está dirigido a pues administradores de organizaciones de ingeniería pequeñas. Es pues un honor para mí presentar al doctor Laporte, que en esta ocasión nos va a dar una conferencia acerca del aseguramiento de la calidad de software, precisamente sobre estas series de estándares y guías para muy pequeñas entidades. Doctor Laporte, thank you very much to accept to be with us in this conference, where you share with us your expertise and knowledge. Please go on.
Thank you very much. And thank you for the invitation. I'm very pleased to talk to you this afternoon. So as you can see, the title of my presentation is an overview, because in 1 hour, I cannot cover everything in software quality assurance. So I'll be presenting to you a very brief overview to allow you to discover maybe new software engineering practices that you can eventually learn and put into application. So as it was mentioned before, my school is an engineering school of about 11,000 students. And one particularity of our school is that our undergraduate students have to go in industry and work as an employee of an industry during their 3-year at ETS. So they spend about 4 months or an equivalent of 1 academic session in industry, and they come back and forth between ETS, learning in class, and then they go back to industry to put in practice what they've learned. And as you can see, we have different programs, and one of which is the software and IT engineering of about 1,700 students. So my participation in software engineering, since I've been involved for many, many years in software engineering, I've been working at the Department of Defense. I've been working for about 25 years. And when I was a professor at the Military Academy, I was a project manager to establish a master's degree in software engineering back in 1989. And the first graduate graduated in 1991. And I was also the project manager to establish a software engineering center in Canada. And then I worked for a military contractor that develops a defense system, as you can see. It's a missile defense system. And my job was to coordinate the development and documentation of software engineering processes, system engineering processes, and also project management processes. I've been working as a consultant also for different companies like Bombardier Transport and the Montreal Subway. And 22 years ago, in year 2000, I became a professor at ETS. And since 2002, I've been working as an expert delegated by Canada on the development of ISO standard. So this afternoon, we will cover those topics. After an introduction, I'll present to you an overview of software quality assurance practices, and I will be presenting to you also an overview of the ISO 29110 standards for very small entities. So very small entities are an enterprise organization, a project or department having up to 25 people. And also, I'll be talking briefly about system engineering standards, and the benefits of those standards for industry, and with a short conclusion. So the challenges today. So companies, they want all of that, preferably as cheap as possible, as fast as possible. But the secret is as follows. You have to have as a first objective to produce quality software. If your first objective, if your priority is to produce quality software, then you are increasing your confidence that you will be producing software faster, cheaper, you'll be more productive, and you will be delivering the software to your customer within the schedule. So all of us make errors, okay? And those errors will eventually become defects, and those defects could eventually become failure. And let me give you two very recent examples of failure. The first failure is a small one, okay, low criticality, where people, owners of Tesla cars, were not able to get in their car because there was some problem with the application. The second failure is much more critical. It is a failure which could activate the emergency brakes of a car. So you can imagine that you're driving on the highway at 160 kilometers per hour, and at the back of you, there is a big truck following you, and then for no reason, the car will activate the brakes. So you can imagine that you could have the truck that will hit your car and it maybe crash your car. So what we want to do in software engineering and in quality assurance, we want to see how we can prevent errors, how we can detect defects. And what I want to say is software engineering practices can help you prevent errors and also identify and correct defects. So software quality assurance, see quality assurance as a toolbox, having different tools that are used depending on the type of projects. So as an example, if you are building a small house for the dog, you will need a few tools. But if you're building a little house for the garden, then you may need different sets of tools because you may also have some electricity or other things. But if you're building a family house, then you'll have to add other tools because you'll have some plumbings and other things. And if you are building, let's say, a medical building, then you may have different technology to add. And finally, if you are building a skyscraper, it is evident that you'll be needing very sophisticated tool to build a skyrise. So the message is, in software quality assurance, as well as in software engineering, you have to select the appropriate set of tools for these specific projects. So let's walk around the house of quality for a few seconds. So at the foundation of the house of quality, you get from starting from the left side, standards and models, defect categories. We have configuration management practices, reviews. I'll be talking about reviews in a few minutes. We have measures, policies, verification, validation, management of suppliers, the cost of quality, ethics, business model, and risk management, amongst others. And this is put in place and verified by people in a quality assurance team or a quality assurance department, depending on the size of the company. And all this is allowed because there is a strong management support. And my question is what do we mean by a strong management support? So what by strong management support, we mean that management defines why software quality assurance practices are important. The management will provide the resources to conduct those practices, and also management will develop a rewarding and sanctioning mechanism to make sure that SQA will be put in practice. So since we are human beings, so people can adopt practices quite easily, and some other people will be resisting to the adoption of practices. So this is why we have rewarding and sanctioning practices. All that is documented in a small quality assurance plan, which could be a page or two for a small project, or which could have 40, 50, 60 pages for a very large project. And this will allow an organization to have stable processes and capable processes. I'll show that to you in a few minutes, and deliver quality software, continuous improvement within the company, and have motivated and productive employees. So this afternoon, we'll have a look at those 5 boxes: standards and models, quality models, reviews, policies, processes, and cost of quality. Let's start with the cost of quality. I'll let you read this. So let's have a look at the component of the cost of quality, or let's have a look at the component of project cost. So project cost, if we were perfect, 100% of the cost will go into the cost of performance, developing the software and developing the documents required to document the software. But we know that we are not perfect, so we have to do some evaluations. We have to do reviews, inspection, tests, verification, and audits. And if we are intelligent, we will be learning from our mistakes and put in place prevention measures like improving on the training, improving the methodology, buying new tools, collecting metrics, and putting in place standards. And the last cost category is what we call the cost of correction or the cost of rework. And by cost of rework, I mean when you find a defect in the code and you discover that the defect is caused by a wrong or incorrect requirement, it means that you have to go back in the development cycle, you have to modify the requirement, you have to modify the test cases, you have to modify components of the architecture, modify some code components, and start testing again. So this is what we mean by rework. And my question to you is, what is the percentage of rework in your project? That you think about that for a few seconds. Maybe you have never thought about this, okay? But if you think about it for a while, you may find out that you're wasting a lot of time, a lot of effort, a lot of energy in the cost of rework, in redoing things over and over again. So let me show you a citation, and I want you to guess what is the number hidden behind my blue rectangle. So the number is about 40 to 50%. So what it means that according to this author, and this is the number that I've seen many, many times around the world, whether it is in America or in European country or in Asia, is 40 to 50% is a good number for non-mature organizations. And it is an effort or waste that could be avoided if we did the thing right. Okay, but the message that I want to show to you today is if you don't change anything, you cannot expect the situation to improve by itself. Okay, there is no miracle in software engineering. Nothing will happen by itself. You have to put in place appropriate practices if you want to reduce the cost of rework. And let me show you a real example from a real company. And this is the curves that I want to talk about for a few seconds. So there is a curve about the cost of non-conformance or cost of rework. And there is another curve about the evaluation and prevention costs. Remember what I've showed you a few minutes ago about the different cost category. And back in 1988, when that company was at level, maturity level 1, the cost of rework was about 41%. And as the company invested in prevention and evaluation, the cost of rework went from 41 to 18, then to 11%, and then eventually to 5%. So the message here is if you want to have more efficient processes, more capable processes, and you want to lower your percentage of rework, you have to do some investment. And as you can see with my red curve, after a couple of years of investment, then you can see that somewhere in 1993, 1994, the curves, the investment curve started to get lower and lower. Okay, and that makes sense, right? So you do your investments, okay, and then you gain the benefits, and this is why you see the reward curve going down. Let's have a look at another part of the house of quality, the processes, policies, processes, and procedure. You can see the pyramid at the top about policies. The policy statement explain why things have to be done in such a way in a company or in a government organization. The processes explain what has to be done, who will do what and where. By where, I mean during the process, during which activity. Procedures explain how and using what. By what, I mean what the tools that are going to be used to execute those procedures. And the quality records are the proof of execution, the proof for an external auditor that the processes and the procedures have been executed. And all that as objective. And the objective is to increase the visibility of the processes. That is what you see on the left side. By visibility, you can see that from the lower part, you have no visibility in the process. And as you go up on my slide, you see that we are measuring more and more the different processes, components, the activities, and the tasks. And that allows us to have on the right side capable processes. By capable, we have a high level of confidence that our schedule estimate is good, that our budget estimate is good, and that our productivity estimate is good. So we know that we have capable processes. So the objective of the policies, processes, and procedure pyramid is to help you in defining and improving the visibility and the capacity of your processes. And this is an example of a real company called Siemens. And here you can see a dashboard with 6 evaluation criteria, where we have customer satisfaction, the cycle time. Cycle time is how much time does it take, let's say, to develop 1,000 lines of code. And as you can see, the cycle time is going down, productivity is increasing, process maturity is increasing, and the quality is increasing. By that, we mean the number of defects, or the density of defects is going down as the quality is improving, and the technology footprint indicate that we are getting more and more mature. The difficulty is to progress in the same direction for the 6 criteria in parallel. Okay, so by putting in place good policies, processes, procedures, and gathering data, we can make good decisions about where to invest money and time to improve the quality of the process and the quality of the products. Let's have a look now to another part of the house of quality. It's called the quality models. And here I'm showing you the standard, the series of standard, the 25,000 series of standard about quality. And you can see at the top level that we have different quality characteristics. Starting from the left, we have performance, we have then compatibility, usability, reliability, security, maintainability, and portability. And the standard defines for each of them sub-quality characteristics that you see in the lower box. A good news is a consortium an American consortium has succeeded in automating the measurement of 4 of those quality measures. In other words, it means that you can specify in the requirements not only qualitatively, but also quantitatively each of those 4 quality characteristics, and there will be a software tool that will measure if you have achieved those 4 quality characteristics. This is fully automated. I suspect that the consortium is working also on other quality characteristics. And for information, those are the members of the consortium, so you can recognize well-known companies. Some of them are very, very huge, like the Airbus or the BMW company or the Microsoft. And one of the results of their work is the publication a few months ago of a new standard. And as you can see on the title, it's about automated source code quality measures. So we have, in other words, we have moved in the right direction in specifying quality characteristics and evaluating and measuring quality characteristics. Let's talk about another part of the House of Quality, about review. I'll let you read this definition. So as you can see, it's a process, and the process is conducted typically during a meeting where some document, some work product, or even a process, because not only a software work product have defects like the requirements document or the architecture document or the code, but also software engineering processes also have defects. So we have to review the processes as well as the product to identify and remove defects. And the good news is when you are performing software reviews in an organization, you are learning at a very fast speed because you're learning from your own mistakes when you're doing reviews, as well as you're learning from the mistakes of others. And this is why 1 year in a context where you do reviews like walkthroughs or inspections is equivalent to about 3 years in another type of organization. So the analogy about reviews and the treatment of water from a river is as follows: is you have water coming with bacteria, and at each step of the treatment of the water, you put in place filters, and you measure at each step the quality of the water, and you put in place a finer filter, much finer filter, and very tiny filter, and at each step you measure, and at the end you have drinking water, safe drinking water, with a known quantity of bacteria or things that is safe for you to drink. Okay. Nothing is perfect in life. There are still a few bacteria left, but they will not harm you, supposedly. Let me give you a real example from a real company called Northrop Grumman. That company is involved in high technology sector. So what you can see is that on the bottom of the slide, you have the different activities of a development cycle. And on the left side, you can see the defect detected. And here you can see that 49% of the defect were injected in the requirements activity, and another 21% of the defects were injected in the architecture activities. So it means that 70% of the defects have been injected before one line of code was written. Here I'm using the waterfall or the cascade life cycle, but the concept is applicable to other type of life cycle, of development cycle. So one message here is, even for a very high-tech company, the number of defects or the percentage of defects injected in the requirement is very high. And so that means that if you don't detect those defects right there on the spot, those defects will eventually will be eventually implemented in the architecture and the code. And this is why you have a very high level of rework. So 70% of the defects were injected before code was written. But unfortunately, most organizations use only testing to discover those defects. And testing comes very late in the development cycle. So now you understand why you can waste 40 to 50% of your budget or your effort in identifying and detecting defects. But there is a good news, okay? The good news from the same company is you can detect defect with a high level of efficiency exactly where they have been injected. So if you look back again at the requirements activity, the graphic shows you that 96% of the defects that have been injected in the requirements activity have been also detected in the requirements activity. So again, we are not perfect. If we were perfect, it would be 100% all over the place. But we are not perfect. But we know that we have, if you remember my water treatment analogy with a different set of filters, it's this analogy here is for each activity of the software development process, there are filters to detect defects like reviews or testings. Okay, so you can, so the good news is you can detect a very high level of defects during the process. Let's move to another dimension of the presentation. I will be talking about standards and see standard as sources of codified knowledge. By that we mean we have extracted from projects that have been successful and from thousands and thousands and tens of thousands of projects which have failed totally or partially. So from both successful and failed projects, we have extracted lessons learned and we have documented those lessons in standards. So if you want to learn quick, I would suggest not to reinvent the wheel, but to use standards because standards documents codified knowledge. So let's have a quick walkthrough to the portfolio of standard developed by the committee that is responsible for software and system engineering standard, the ISO committee SC7. So we have a standard about vocabulary. We have a standard about the body of knowledge. The body of knowledge defines what a student should know before it graduates and before it gets to an industry as a professional. We have life cycle standard, and by definition, life cycle standard covers everything from the minute you have an idea about a project until the time that you retire this software product to introduce a new one. And naturally, 29110 stands here, and I will give you a few slides about the 29110 standard. And we have a series of standards about documentation, one standard about requirements engineering, two standards about the architecture. Here there is a family of standards, the 29119 series of standards about testing, standard about software maintenance, about project management, about risk, about measurement, about quality, about software size measurement, and about tools and methods. So as you can see, there are standards to cover every aspect of software engineering. But as everything in life, there are advantages and disadvantages. So on the left side, I will let you read the advantages of standards. But to apply standards correctly, you have to be aware that like any other technology, like a new methodology or a software language or a new tool, there are things to consider when you want to implement those technologies. Okay. You have to be aware of them. And the cost of buying a standard is very minimal comparing to the cost of implementing the standard. because when you are implementing the standard, you are extracting elements of the standard to embed them, to put them, to insert them in software engineering processes. Okay. So this is the job that a software process engineer has to do. Now let's have a look at the 29110 series of standard, for which I am the lead editor. So to give you the importance of very small entities, and I want to remind you that very small entities are organizations which have up to 25 people. So one of those entities at the bottom of this pyramid, oh, I forgot to mention that this pyramid is a real pyramid from a real manufacturer of electronic products. And as you can see at the top, you have that company, that Japanese company, which is very well known around the world. And the second line is their prime suppliers, 60 of them. Then they have low-level suppliers, 600. And at the bottom, you have 6,000 producers. So a software defect was produced in a component developed by a low-level producer and was integrated into the product. And eventually, the cost of that defect was about $200 million. So my message here is that if you remember my definition about VSEs, is there are VSEs at each level of that pyramid. Even in large organizations, there are small teams and small projects that can use 29110. So the standard has been developed under the SC7 committee, and my working group 24, as you can see, has been established in 2005, and the flags that you see are the flags of the country that are participating to the development and the maintenance of the 29110 standards. And at the bottom, you can see the logo of the 4 professional associations. On the left side, you have Systems Engineering Association, and on the right side, you may be aware of the IEEE. So to help VSEs, we have developed a roadmap of four guides. The first guide is a guide for startups or for a VSE that produces very small projects, 6-person month project. Then we have produced a guide for a VSE that has one team working on one project at a time. And as that VSE will grow, then maybe that VSE will have multiple projects in parallel with multiple teams. And we want also to help make sure that the VSE will sustain and grow and stay competitive around the world. Now let's have a look inside one of those guides, the Management and Engineering Guide. So you may be surprised by the fact that there is management. The reason why we have introduced a management process in the guide is because if you don't do proper project management, even if you have bright software engineers, your project may fail, or you may fail to deliver within budget or schedule your software product. So you have a customer that knocks at the door of a VSE with a list of needs, list of requirements, and the management of the VSE will decide if it has the capacity and the competence and the time to do this project. And let's say that the VSE says, yes, we want to do this project. Then the project management process will be triggered, and the VSE will do project planning. Then the VSE will execute the project plan, and that will start the execution of the software engineering, the technical part of the software engineering process. And this will start, and somewhere during the process we'll be evaluating against the plan, because as you know, we have risks, we have surprises, and sometimes we don't meet the calendar, sometimes we don't meet the budget, so we have to evaluate against the plan, and if we have to, we make correction to the plan. And eventually, we have completed the project, and we will be delivering the software to the customer. And by configuration, by software configuration, what I mean is we are going to deliver to the customer whatever he has requested. By that I mean, yes, we will be delivering the code, but maybe the customer also wants a user guide or an installation guide or other things. So whatever the customer has requested, this is what we call the configuration of the software. Now, even though the boxes that I've shown you, the white boxes, looks to be like they are a waterfall or cascade, look at them as Lego blocks. So you can assemble those Lego blocks the way you want using the life cycle that you prefer. Let's have a look now at a task of the requirements analysis activity. So in the guide, each step of the guide is documented this way. On the left side, you have the roles. In this case, we have a customer and the analysts that participate to this task. And the task is to validate the requirements and obtain the approval of the customer about the requirements. And we have some text that gives you more information about this task. We specify that the input for this to accomplish this task are the software requirements that have been verified. And by verified, I mean, as an example, that you have done a review, a software review to identify the defects, and you have corrected those defects. And once the document has been reviewed, then the status is verified. And the output, once you have executed the task, the output are the requirements specification that have been validated and also approved by the customer. And you have a document which demonstrate that this task has been successfully completed. Now let's have a look at real example of VSEs that have implemented 29110. So a startup in Peru, I had the opportunity to go to Peru 3 or 4 times before the pandemic, naturally, and I met the owners of that startup. So that startup with 2 graduates from the software engineering program of Lima decided to create a startup, and they did a project of 800 hours with a percentage of rework of 18%. They used a basic guide using an agile mode with 6 sprints. Then there was a cosmetic developer in the area of Montreal. It's a small company with 20 people, with 1 software developer, small project, and 12% rework. And there is another startup, 2 people, about 1,000-hour project with 12.6% rework, using, again, the basic profile. Here, we have an example of a very large organization. It is an organization that provides electricity here in Quebec to 8 million people. And in this organization, there is an IT division of about 2,000 people that supports about 2,000 applications. So this is if you remember my pyramid before, this is like the top of the pyramid, right? So, but as I said, each pyramid has a lot of levels, and there are at the bottom of that pyramid, there are small teams and small projects. In this case, it's a small team of 11 people that work on the basic profile with Scrum with 4 sprints. And it was a 1,500-hour project with 9.6% rework. So why am I mentioning the rework? You remember that curve that I showed you a few minutes ago? So the startup was here, 18.6%. The other startup was here at 12.6%, cosmetic company at 12%, and the utility provider at 9.6%. So what I want to show on this curve is that if you implement proven practices from a published standard like the 29110 standard, you are accelerating the maturity of your organization. So instead of having 40% rework when you create or start up your organization, then you start your first project with 12 or 18% of rework, and eventually you may go to eventually lower percentage of rework. So the message again is, do not reinvent the wheel. Please use published standards. And I have good news for you. The guides have been translated in different languages, but one of the translation in Spanish translation. And the good news is the guides are free. So you can download the guides from ISO. And if you don't find them, please contact me or contact your professor, and I will send to your professor the copy of the Spanish version of the guides. For your information, we also have in 29110 a series for VSE that produces systems. And by system, we mean that there are software and hardware components, like your iPhone or your telephone or your computer. Okay? So what we have done is we have done a roadmap, identical roadmap as the one that I've showed you just a few minutes ago. And we have produced guides, a very similar guide. So this is a very similar guide that I've showed you before. But in this case, if you look on the right side, we are at the system level. So it means that when it's time to construct the system, it means that people will have to buy some hardware, buy some electronics, or develop some electronic, maybe buy some and develop some software. And this is the place where you will be using 29110 for software to develop software components. And once all the hardware and software have been constructed, then the next step will be the integration, etc., etc. So for your information, if you read French, then you can have access to my book that I wrote with co-authors from system engineer colleagues from France on the left side, and a document that was published 2 weeks ago by IEC. IEC is the International Councils on System Engineering. IEC has about 19,000 members in different countries. So the last word about 29110, what is in red is what is implemented in the guides, the 29110. So we didn't want to have too many processes in the guide because this would have been too complex for VSE. So we have decided to have only two processes, the management process and the technical process, and to put in those two processes different components like configuration managements, like traceability or risk management tasks to facilitate the job. Now that we have developed those guides, we ask ourselves in 2018, did we do a good job? So we decided to ask the VSEs, and we asked them, are you satisfied with the result of the implementation of 29110 in your organization? As you can see, and we asked them about quality improvement and productivity improvement. And as you can see, 89% of them were completely or largely satisfied about their results. And the results is obtained in a few weeks or in a few months. So you can see very fast, very quick improvement to the quality and productivity of the VSE when you implement 29110. So on one side, we have happy VSEs. We also wanted to see if the customers of those VSE were happy. So as you can see, 79% of them were completely or largely satisfied with the product that they received from VSEs. We also asked academia why they were teaching 29110 or using 29110 for projects. And as you can see, one of the reasons is to teach students basic software engineering practices, basic project management processes, to teach 29110, to teach software quality assurance, etc., etc. And for information, when we did the survey in 2009, we were told that even some country had been teaching 29110 for 9 years. So now we are in 2022. So now you can see that some universities have been teaching 29110 for over 13 years. And here there is a quick look at the countries, known countries that are teaching 29110. And yes, Mexico is on the slide. I've been working with many states in Mexico, mostly in Zacatecas, with CMAT and researchers and professors from different states of Mexico, as well from different countries in Latin America, to help implement software quality assurance in 29110. Here you can see that we have, here we can see that we have a lot of components within 29110, but I want to show you the latest one. We have an agile software development guide, which should be published in 2022. And we are working on an agile DevOps guide, which should be published in the late 2022 or in 2023. And we are also involved in space. We have a guide, and we have also a specification for 6 space agencies around the world that have decided to adopt 29110 to help their suppliers in developing quality software for them. So there are many benefits to 29110. I'll let you read the day-to-day benefits. But also, there are business or commercial benefits with 29110. By commercial, I also include government organization, because government organization, they have also hundreds and hundreds of software developers that develops tools or application to provide services to the government agencies or to citizens. So the benefits applies to companies as well as to government organizations. So those are very positive benefits that we have collected from VSEs that have implemented 29110. If you want to learn more, please look at my website at the university. You have information in 3 languages, including in Spanish. So today I had just time to quickly walk through only five boxes of the House of Quality. And if you want to know more, this is my marketing pitch. If you read French, then you can have a look at the left side. The blue book, the dark blue books are in French. And if you are reading English, then you have on the right side, the light blue book that has been published a few years ago. And the good news, if you are a member of IEEE, and you have access to IEEE Explore, you can download the 13 chapters of the book from the IEEE Explore site at no cost. It's free. So if you're a member of IEEE and you have access to IEEE Explore, you should be able, from your account or from the university account, to download the 12 chapters of the book. Now, the good news, as it was mentioned at the beginning, is that the translation in Spanish has been completed in 2021, and it should be published in 2022. And also there is a Chinese translation that should be available in 2022. So why am I showing you this? So you can see that the book will be available in 4 languages, mainly the English, the Spanish, and the Chinese languages, as well as the French. So it means that it has a very wide coverage. So it also means that there is a very new level of interest in software quality assurance. So a few years ago, software quality assurance in many companies meant testing. So software quality assurance department were only people doing testing. But because software is getting more and more complex and bigger, and you could have security flaws and things like that, software quality assurance is becoming more and more important. And this is why, I guess, countries are spending or investing time and money to translate the book in Spanish and in Chinese. So the objective of the Spanish translation is to provide to use the students in Latin America and the professor a book that you can read easily. So conclusion, there is a wide spectrum of proven software quality assurance practices that are available for the development of quality products. Okay, when I say available, since the mid 1970s, so 1973, 1975, the first, I would say, one of the most important software quality assurance practice. I mean by that, the review technique like inspection, originally developed by IBM. This has been published in 73 timeframe. So this has been available for the last 50 years almost. So this is why I say available. Software quality assurance can help you increase the confidence about the development of quality products within budget and schedule. Now I say increase the confidence because unfortunately in software engineering, a process or a standard cannot give you a 100% guarantee. Okay? But if you use the proven practices, you are increasing the probability, the confidence that you'll be developing all the functionalities with all the quality characteristics within the budget and the schedule. The 29110 series has been developed for small organizations. We have developed a roadmap, a 4-stage roadmap that will allow VSEs either from the startup mode and even the adults, the more mature organization, to improve their quality and their productivity. So not only software professor and student, but also developers and manager must use the knowledge documented in software engineering practices like software engineering standards. So before I leave you, I want to leave you with 3 questions. So the first question is, why do a large number of software organizations either ignore the existence or don't use software practices that have been available since the 1970s? Why are so many software people not working smarter and not using the proven practices? Why? Why are so many managers and developers not learning from their mistakes? I told you before that software reviews, when you discover defects that you have injected, if you are bright, okay, you will learn such that the next time you will not be doing the same mistakes again. And by doing reviews on the products, on the components, and on documents produced by your colleagues, you will be also discovering and learning from the mistakes that they make. Okay? And my hypothesis is maybe it's because many developers and managers have a big ego. Okay? They say, oh, I'm too intelligent to use a process. Oh, I'm a senior software developer. I don't have to follow a process. I don't have to follow a template. I don't make mistakes. Hey, I am a senior software engineer. I don't make mistakes. Again, if you remember one of my slides before, everyone makes mistakes. Everyone makes mistakes, okay? So a few suggestions for you. If you are looking for your first job or your next job, based on the presentation that I made, is select an organization that has used documented process to develop their products. So if you are going for a job interview, okay, you bring your curriculum vitae, your resume to your potential employer, but you should also ask your potential employer to show to you their process, because you want to know if you're going to work in an organization which is well structured as a documented process. So you could ask the manager or the person that is interviewing you, please show me your software development process. Then you could select an organization where doing software review is work as essential to develop quality products. Again, you may ask the people that will interview you to ask them if they are doing software reviews. Select an organization that already improved its process, its tool, and its training. So you may ask one question to the person that will be interviewing you, please, can you describe to me the improvement that you've done to your process, your tool, or your training during your last 6 or 12 months? select an organization that will allow you to learn, okay? Okay. And also select an organization that will allow you to learn from your mistakes and also from the mistakes of other people, and select an organization that measures its process and the quality of its software product. Sorry, I skipped this one. Because if you don't measure, how do you know the quality of your process? How do you know the productivity of your process? How do you know the number of defects injected? How do you know the number of defects detected and corrected? How do you know the number of defects delivered to your customer? How would you improve your software estimation capability? Without measurements, you cannot do that. So with this, I thank you very much, and I'm ready to answer your questions.
Thank you very much, Professor Laporte. And now we'll go to the question. Iniciamos con los que están conectados en Zoom. Doctor Noé, adelante, por favor.
Sí, muchas gracias, Dr. Gerardo. Thank you very much. We have a question from Fernando Sanchez. Have Agile methodologies helped to improve project quality?
Any methodology, if you do it right, okay, if you put in place the components of the house of quality that I've showed, any methodology, if you apply it correctly, should improve the quality. But, okay, like any tool, okay, as an example, with a hammer, you can get a nail in, and with a hammer, you can get a screw in. But the hammer is not the appropriate tool to get a screw in the wood. So for every type of project, you should select the appropriate methodology. And if you put in place the practices that support that methodology, if you remember the house of quality that I've shown you, there are different methodologies that you have to put in place. There are different components that you have to put in place to improve the quality of your process and the quality of your product. So whatever the software lifecycle or the software development cycle that you use, okay, first you have to select the most appropriate one. Sometime, for some reason, a customer may impose on you a life cycle or development cycle for some reason. Or as an example, when you are working as a supplier of a large projects that are developing hardware, many companies are still using the waterfall or cascade, even though companies are migrating now to agile development methodology. So we have to adapt the methodology to the context of the project and put in place the components of the house of quality. Because even if the methodology is the appropriate one, if you don't put in place the appropriate set of tools, you may not produce software with the quality, the functionality, within the schedule and the budget of that project. Did I answer your question?
I think so. Thank you very much. We have another question from Ms. Flores Orozco. When software development is applied under agile approaches such as DevOps, how much quality is lost?
Okay, that's a good question. But what I would say is this. Let's say that you've been working with the waterfall approach for a few years because your company have been working for a few years, and you have a process that is stable and capable. Remember, I showed you a slide where if you do the right things, you can have visibility on the process. You measure the process activities. You measure the process task. You measure the number of defects injected and detected. So if you put in place a new methodology, okay, yes, for the first project or two, you may lose a little bit about from the previous data or the metrics that you were collecting from previous project, because when you introduce a new methodology, it means that people have to learn. People have to learn a new process, people have to learn the new tools, and the roles of the developers will be changing. So maybe for the first one or two projects, the metrics, the capacity metrics, the productivity metrics, and quality metrics may go down a little bit because you are in the learning mode. But if you do it right, if you're doing it right, then you should recover your performance quite fast.
Okay.
Did I answer your question?
Yeah, thank you very much. And the third one is from Cesar Merino Ibanez. What should be the first step for a VSE to take to improve its processes with these quality standards?
Okay, so my answer, and I am biased, okay? You know that I am biased because I am the editor of the 29110 series. So my suggestion to you is this. It is like, I don't know if you do cooking, okay? Because I do cooking, okay? But when you do cooking, and especially if you want to cook, let's say you want to cook a chocolate cake, and you look at the picture and you say, oh, that looks great. That looks like a very delicious chocolate cake. You look at the ingredients and you say, oh, yes, those are the ingredients I would like to eat. Then, if you have never done a chocolate cake before, what are you going to do? You are going to follow the recipe, right? You are going to follow the recipe for the first time. And this is what I'm telling you, is 29110 is providing you with a recipe. Each step of the process is described with this notation. So as when you do a chocolate cake for the first time, you follow the recipe, and maybe you may find out that you want the next time eat what your chocolate, let's say the output product was great, but you say, I would prefer to be a little bit different, and next time I will be modifying these ingredients a little bit. I will add a little bit more sugar, or I will add a little bit more chocolate, and then you will do again your recipe, and you get the chocolate cake, and you may say, oh, this is exactly what I want, and then you have a stable process, you have a stable recipe, and you'll be using this chocolate cake recipe for the next 5, 10, 20 years, part of your catalog or portfolio of recipes. So with 29110, we are providing you with everything you should be doing, okay? We are providing you with a guide. If you remember, we are providing with a project management process and a technical process. Now, the reason why, and I did hint at that a few minutes ago, we know that software developers, normally they are good at the technical aspects. Okay, they have been learning for many years how to code, how to develop requirements, the architecture, and to do tests and things like that. But most of the time, in many, many, many universities, they have never learned how to manage a project. So, but what we say is, even though you have very great skills in technical skills, if you do poor management, then maybe you will have, at the end, you'll have chaos. Okay, maybe you will never deliver a software project. Your people will be frustrated because it will be chaos. So this is why we have provided you with, again, like a cookbook, we have provided you with 4 major activities in this process. First is how to plan a project. We want to make sure that you forget nothing. Okay, this is like a checklist. Okay, we want to make sure that you don't forget anything. Okay, that you look at the potential risk of your project and you think about those risks and what you can do about those risks. Because all software projects have risks. All software projects have risks. So don't be blind. Don't believe. You don't have to be fooled. You just have to say, okay, what are the risks in this project? And what can we do now if those risks will materialize? So this is part of the project management. And as you execute the project plan, okay, you are reviewing the output with the customer, and you keeping the customer informed about the progress. Okay, and eventually you may have a risk which will materialize as a problem, and that will create a delay in the schedule. And then it's time to talk to the customer and say, oh, sorry, Mr. or Mrs. Customer, we have a big risk that now is a big problem, and this will bring a delay of maybe 2 weeks to the schedule. Do you agree that we modify the schedule, or do we modify the requirements such that we deliver to you the product within the schedule and with one missing component, and within the next 2-3 weeks after delivery, we will be providing you with the missing functionality, okay? And this is where you will be negotiating and discussing open books with the customer, and then the customer and the project manager will make a decision. But what we are providing you is open book project management and open book technical process, such that there is no surprise for the customer and there is no surprise for the VSE or for the members of the team. So my answer to your question is, please don't reinvent the wheel. Okay, the guides have been available for the last 8 or 10 years, depending on the language. They are available free. Okay, and even some university in the state of Zacatecas even have certified universities. There are 11 universities in the state of Zacatecas that have been certified the same way as a private company have been certified, with auditors coming from IEC in Mexico. They have been audited by the same auditors, and they have received a certificate of conformity exactly the same as a company, because their students, when they're doing their final project, they're what we call in English the capstone project or the team project at the end of their program, they do their projects using 29110 from the beginning to the end. Even some universities are providing software to outside customers. By outside, I mean outside the universities. Some universities are developing software internally to provide support to their professors or to the departments, but even there is at least one university that is selling software to a customer outside the university. And the beauty with this is when the student that has done a project in a team of, let's say, 4, 5, 6 students, they have learned their roles and they have done project management and technical process. When they join industry, they are more mature, a lot more mature than other students. And also they bring with them the experience they had with the 29110, and they may even be the transitioning that technology to their new employer. So I don't know if I answered your question completely.
Thank you very much, Professor. And Dr. Gerardo, we continue with other platforms.
Gracias, doctor. Vamos con los que están conectados en Facebook, para lo cual le pido a Adriel que nos transmita las preguntas.
Hola. Peter López Caballero. Question. To achieve software quality, does it depend on the developer's experience?
Adriel, hay un ruido extraño, no se escucha bien tu pregunta. No, parece que lo perdimos.
¿Ya ahí me escuchan bien?
Sí, mejor.
Sí.
Adelante.
Peter López Caballero. Question about, to achieve software quality, does it depend on the developer's experience?
Yes. Oh, yes. Oh, yes. I didn't have time to cover this, but there's been a study done a few years ago amongst 800 software engineers working in industry. So not students, but engineers. And they have shown that there is a very wide variation in the quality or number of defects injected from one individual to another. And if I remember right, a company called Rolls-Royce, if you know, Rolls-Royce is producing jet engines, and they have found out using measurements that there is a factor of 10, okay, but from one individual to another in the number of defects injected and the number of defects detected. And while I was talking to you, I took this slide. So on this slide, you see on the left side the efficiency of the author in injecting defects, and on the upper part in the efficiency in detecting defects. And if you look on the left side, efficiency of the author, it's defect introduced per 1,000 lines of code. It varies from 0.5 defect per 1,000 lines of code to 18 defects per 1,000 lines of code. So you can imagine here, there is a very wide variation here. And if you look at the upper part of the efficiency of reviewers, it varies between 30% and 94%. So 30%, it means that if someone, if this guy, the author, now F has 30% effectiveness, it means that this guy will detect only 3 defects out of 10 that he has produced. And if you look at reviewer C will detect 94 defects out of 100. So you can see here that there is a factor of 3 in defect detection, and there is a factor of about 20 in defect injection. So yes, there is a very wide variation between one and another. The good news is you can help the people that are injecting a lot of defects, okay, by providing them with a good process, by doing reviews on their work product. And also, there is also a good news for the defect detection, okay, because you can learn how to detect defects and you can improve your capacity in detecting defects. Now, I do not mean by that someone that starts at 30% will achieve 94%, but most probably, if that individual learn how to do reviews, then he can maybe double his efficiency in defect detection. So yes, the expertise, the experience of people have an impact on the product. But if they have been well trained, if they have, let's say, software engineering curriculum where they have learned how to develop software requirements, how to develop software architecture, etc., etc. And if you are providing them with a good process, because the process will guide them at each step of the product development, then you have to deal with the employees that you have and improve their capacity. Okay? Because everyone would like to have, let's say, if you look on my slide, the developer A, which injects only 0.5 defects per 1,000 line of code, or have someone like the reviewer C that detects 94%. But as we know, in every company, we have a wide range of people, and we have to use whoever we have. And the good news is, even if you are low productive, okay, you can improve your productivity. You can learn. Now, I didn't mention that, but I have to mention that. If you, let's say you have developed our first project using 29110, and then a new customer knocks at the door of your company for another product which is similar to the first product, then it means that you have already done most of the job for the first customer, right? You have already did your project plan for your first customer. So for your second customer, you may be reusing 80%, if not 90% of your first project plan, because it will be quite similar from one customer to another. Now, also for all the other documents on the right side, the requirements and the architecture and things like that, most probably the new product will be similar to the first one. So maybe 80% or 90% of the documents that you have produced for the requirements or for the architecture will be reused again for the second product. So if you are doing a good job in producing your documents the first time, if you are doing reviews to remove the defects, then the first time you may be going a little bit slower. Maybe your productivity will be a little bit low, but as you do a second project or third project and a fourth project, both your productivity and your quality should be higher and higher. because you will be developing higher quality products. You will be reusing documents which have less defects, and your productivity will increase. So you should become more competitive, right? Remember, if you are in competition with people of different percentage of waste, okay, if you are producing only 11% of waste and your competitor is producing 30% waste, then you are much, much more competitive. You will have more profit, or you will have money at the end to invest in improving your product or improving your process. Again, as you can see, there is no magic formula. Nothing will happen by itself. It is hard work. It is software engineering. Okay? It is software engineering. It is not computer science. Okay? There is a different mindset. Computer science is mostly, and I am let's say that it is not as black and white that I'm describing, but on one side of the spectrum, you have computer science, which is developing software components, okay? And on the other side of the spectrum, you have software engineering, which are developing not software components, but software products, okay? You are developing a product. You are engineering a product with functionality and quality. And a product which could be operated or used for many months, for many years, or for many decades. If you look at some products that have been, let's say, put in airplanes, okay, so there are airplanes that have been flying for 40 years with software that have been developed in the 1970s. Okay, if you go in the banks, big banks, they have developed software 20 years, 30 years ago, and they're still using the software today to operate the banks. So this is why we have a different mindset when we are having a software engineering mindset. So we have to think that we are developing a product, so we have a liability, we have a responsibility, and we have to think that we have to document this software product because it could be used for 10 years, for 20 years, for 30 years, and as I showed you before, if you have a defect, that defect can cause a failure, and that failure can hurt people and can even kill people. So software engineering mindset is quite different from the computer science mindset. Other questions?
Yes. Another question, Peter. Why do my clients not believe in software engineering?
Sorry, I do not understand you. Can you talk louder, please?
Okay. Do you hear me?
Yes, but louder, please.
Okay. Why do my clients not believe in software engineering?
Well, okay, so it depends. If your teams have been educated in academia, in universities, like we do at ETS, okay, remember, let me show you again the slide. Remember that slide that I've showed you, okay? Remember that we send our students in industry 3 times during their 3.5 years of training, okay? They come to ETS and they stay in class for maybe 2 or 3 semesters, and then they go in industry for 4 months. They come back in class for 1 or 2 semesters, and they go back in industry. And then they come back, and then they go back again in industry. So they do that 3 times. So by the end, okay, they have learned something. They have learned that what they have learned in class is applicable, could be applied, and is applied in industry. Okay, so they have learned in class, and they have discovered how it is implemented in industry. So this is one of the secret about convincing, if I could use this expression, that whatever you have learned in class is used in industry, is by sending your students in industry for an internships, like we do 4 months at a time, 3 times, And those students, as it shows on my slides, they are being paid as an employee during those 4 months. Okay, so they are as responsible as another employee when they are developing their software. Now, going back to your question also, is if your teams have not been trained or educated in software engineering, then you have a long way to go. Okay, because again, there is no miracle. Okay, it's not by looking at the slide presentation like myself that they will have what I call a conversion, instant conversion between what I call the computer science mindset to the software engineering mindset. By the definition, education provides you, university provides you education. Okay? This is why we stay in university for a few years, for the education. Okay? For training purposes, you go in a company or you go in a class for a day or two. But for education, it takes time because it takes time to learn and it takes time to change your mindset, your attitude. Okay, your attitude that, there's no problem if I make errors, I can correct them, no problem. Okay, but every time when you think like that, you're forgetting one thing, that when you're injecting defects, you're wasting time. And when you're injecting defects, your quality goes down. So if you don't detect the defects that you have been injecting, then someone will pay for that. The customer, the user will pay for that. Okay, because the software will go down, or there will be some attack. Some hackers will get into the software because there is deficiency in the software. So I would say to get the correct mindset, you should be hiring, ideally, people that have gone through a 3.5 or 3-year undergraduate degree in software engineering. By software engineering, I don't mean one course. I mean 8, 9, 10 different courses in software engineering, like we have at ETS. Okay, different courses for different topic. As an example, we have a 1-semester course on requirements. We have a 1-semester course on architecture. Okay, we have a 1-semester course on testing and maintenance. Okay, we have management course. We have a quality assurance course. So it takes time to modify the brain cells, to convert the brain cells from the coding mindset to the software engineering mindset. So unfortunately, I would like to tell you that there is a pill that you can take, and the next day you wake up as a software engineer. But the pill it's a 3-year undergraduate degree. So I don't know if I answered your question.
No, that's all. Thank you very much, Claude.
Thank you.
Gracias, Adriel. Pasamos ahora a la sección de conectados en YouTube. Josué, adelante, por favor.
Gracias, doctor. Thank you very much, Dr. Laporte. Very interesting talk. We have some questions here. The first, the Professor Juan Carlos Rojas, Sanidad. What are the standard or quality model in relation to preventing failures?
To what? Can you repeat again, please?
All right. What are the standard or quality models in relation to preventing failures?
It's the last word that I don't understand.
Errores. Mistakes.
Mistake.
Oh, okay. I'm not sure if I understand correctly, but if I go back to, let's say, the slides about reviews, remember that I showed you this slide about reviews, and I list the standard at the bottom of here you can see it's the IEEE 1028. So the IEEE 1028 standard from the IEEE, which you can download from the iExpro website, is a standard that describes different review techniques. different review approaches like inspections or walkthrough. So you can download or acquire this standard. Or you can acquire books. There are at least 2 books that have been written about how to perform, how to conduct software reviews and software inspection. Did I answer your question?
All right, just next from Alan Garcia, the Senate. Thank you very much for the lecture. It's very clear the stamp brings use great benefits. Why is their implementation complicated in the institution?
Okay, on one side we have, as I showed you before, on one side we have a lot of standards that will guide you in developing quality software. Remember, I showed you before that there are different standards that will help you. And standards, if I can remind you, standards are documented knowledge, right? So I want to show you this slides. Sorry, yes, this slide. Okay, so on one side we have people that have been working over the last 40 years, because those standards have not been produced overnight. Okay, because we have been learning, and every time that we learn, we capture this knowledge, and sometime at a certain point we decide to produce a standard. So on one side we have the knowledge captured by the standard. On the other side we have the human beings, and as soon as you put a human being in the process, you have all sorts of side effects. Okay. If you look as an example, let me take this as an example. It's not perfect, but it is actual. COVID. Okay, after a few months after we discovered that COVID was around, big pharma have produced a vaccine. Okay, the Pfizer and the Moderna and the other guys, and they have conducted trials. And at a certain point, government agencies have said, okay, they are secure, they are safe, and they do protect you against side effects of COVID. So millions of people got the injection. But as you know, I don't know in your country, but in my country and in many countries, you have 10, 15, maybe 20% of the population will say, no, I don't believe in that. So that's the same thing in any company about any technology. As an example, when I say technology, whatever it is, a standard or a methodology or a tool or a process, let's say if you want to implement software reviews, you will have resistance. Okay, you will have resistance from those big egos that say that they don't need to do that because they're bright and they're seniors and things like that. So the reason why it takes time, and let me show you another example that I've shown you before. Remember, I've shown you this slide, and I didn't talk about the years. At the bottom of my slide, you can see there is number 1, number 2, 3, 4, and you have 1998, 1990, 1992, 1994, etc. So what does it mean? It meant for that organization, which had about 400 software engineers in those days, that it took about 2 years to move from level 1 to level 2, another 2 years to move from level 2 to level 3, etc. So why did it take so long? Okay, it's not complex. For those of you who have read the CMM or CMMI, it is not rocket science. Okay, we're not teaching, or it's not astrophysics with very complex algorithms and very complex concepts. It's quite simple, like quality assurance. The reason why it takes so much time is you have to convince the people to adopt the new practice. You have to train the people to use the new practice, and you have to put in place the new practice in projects. And this is why it takes so long to move from one level to another. It's because you have those human beings in the loop, okay? And by definition, many of them will resist. Some of them will jump on the technology, on the practice right away. You have 10% of the software engineer that will see the light and they will say, oh, yes, that will be like I showed you the basic profile, okay? So maybe from the listeners that are listening to my presentation, maybe 10%, 15% of the people that are attending may say, oh, that's great. I will, right after my presentation, I will go on the web and I will download this document, okay? And on the other side of the spectrum, you will have 10 to 15% that will say, no way, never. I will never follow a process like that, okay? So this is life. And I didn't mention you what I did. I did teach a graduate course to people working in industry about the process improvement. And I was saying to my students that were 30 years old, 40 years old, and things like that, that in my course, in my one semester course, it will be about 20% software engineering and 80% psychology or sociology. And they were looking at me and they were like saying, are we at the right place? And as they started to follow the methodology that I was teaching them, okay, they realized that each software practice is easy. The problem is the human people that you have to convince, that you have to train, that you have to improve, that some of them are resisting. Some are resisting a little bit. They need more convincing, okay? Like maybe a presentation like I did today may have convinced a few people to look at practices and adopt, let's say, start doing reviews. So there are people that need a little bit of convincing to adopt a new practice. But as I said, there are people that will never adopt those practices. And it's up to the management to decide what they will do with those employees, okay? In some organization, when you sign as an employee, you have to sign that you will be applying and using the processes of the organization. And if you are not using the processes of the organization, you will be fired. You'll lose your job. Okay, because the company is saying, we have invested dollars, we have invested time in developing our process, in documenting our process, in developing our templates, in our checklists, in training our people. We don't want to waste this money. We want to make sure that people will follow the process, but we are open to improvement. We are always listening to improvement to improve the productivity and quality. If you don't want to play football with us and you want to play soccer, sorry, in our company, we play football. You want to play baseball, you go and find a job in another company. Okay, so this is one way to do the things. Okay, remember I told you before at the beginning about the House of Quality, about management support. Management support has to provide not only the resources, but the motivation, the positive motivation, as well as what I say, the negative motivation. Okay? And negative motivation is if you don't follow the process, we will tell you one time, and the second time you will be fired, you will be losing your job. Or you will be demoted, or you'll be transferred to a low-level project. Okay? That's life. This is human beings, and all over the world, human beings are wired roughly the same way. Okay? So I don't know if I answered your question correctly or completely.
I think so. Next question from Socrates Benitez, Senidet. Thank you for your presentation. Is there a standard for test design?
For tests? Oh, yes. Remember, let me go to my presentation. Remember, I showed you that. If I click, I just want to show you the right one. This one, okay, 29119, about testing. It's a series of about 10 standards, okay? In other words, it's a family of standards. And the 29119-1, I think it's about terminology and concepts. And then the other component is about testing process, testing strategy, testing AI systems, etc., etc. Okay, so yes, there is a complete family of standards, and if my memory is right, the 29119 is also an IEEE standard. So if you are a member of IEEE or you have access to IEEE Explorer, and if you go to IEEE Explorer website and if you type in the standard box 29119, you will see the series, the complete series that you can download at no cost from IEEE. And this series, by the way, is constantly improving. Okay, I didn't mention that, but every 5 years we go and we get into a maintenance cycle where we improve the standard and we publish a new version. So this is what is happening right now with the 29119 series. They are producing now a second edition or a third edition of some of the document to capture, as I said, we are capturing knowledge from successful projects and failed projects. And as we learn, let's say as an example, as we learn about the testing of AI system, then we are learning from the good things that we did and the bad things that we did, and we are capturing this and we are documenting that in one of the part of 29119 standard. So again, the message, do not reinvent the wheel, okay? Don't start from zero. Go and get the standard. Did I answer your question?
Yes. The following request from Alan Garcia. What are the requirements for research stay with you?
Whoops. Can you repeat the last part of the sentence? Because I missed it. The last part of the sentence.
Oh, sorry. Requirement for research stay with you.
Sorry, I don't understand.
Requirements for research stays with you.
I don't understand. The line is not good. I lose you.
I saw
okay. I can read it. It's in the chat.
Right. Yes.
Okay, so that's better. Okay. What are the requirements for research stay with you? Oh, you mean research stay at ETS? I guess so.
I suppose.
Yes. Okay. Right now, if you look at my face, okay, you can see that I'm not 50 years old anymore. Okay. I'm getting a little bit older, so I am semi-retired. So I am closing. I'm closing one after the other. The projects. The only projects that I'm keeping alive is the 29110 series of projects. Okay, because I am the lead editor and I'm working 2-3 days a week full time to improve those documents and produce new documents. So my focus right now is on 29110. So sorry, if I was 10 or 20 years younger, then it will be different. But as we say in French, hey, life is a bitch. Okay, so at certain point we have to leave a few things and just select one or two things to work on. Sorry about that.
No more question for this YouTube.
Gracias, Josué. Regresamos a Zoom. ¿Preguntas en Zoom, doctor Noé?
Yeah, we have a question from Elias Alejandro Ramirez from Cenidet. He says, in Zacatecas City, I had the opportunity to work with ISO IEC 2910, but it was applied to a spin-off created by the university. What do you think about universities applying this strategy to train students while developing real software projects in real companies?
The last part, in what?
About universities applying this strategy to train students while developing real software projects in real companies?
Okay, so again, I am biased. You know that I am biased because I am the editor. But the thing is what you have learned in class. Okay, again, I'm just looking for my slide to show you the slide. So what you have learned in class. Okay, you have learned maybe in a class or in a course about requirements, and maybe in another class or another course about the architecture. And you have learned in many courses how to code, and maybe in some courses you have learned how to test, and maybe you have learned how to do integration. But most of the time, students never had the opportunity to do a project from the beginning to the end, where they see those also as a puzzle with different pieces. So you have received in each course a piece of the puzzle, okay? But you have never assembled the pieces together in a project. So with 29110, you have the opportunity to put every bit of knowledge that you have acquired as a team, working as a team. So you're learning two things. You're learning how to put the pieces together, okay? What are the relationships between doing a requirements and doing a review? Now you discover the benefits of doing reviews. And also you learn how to deal with other people in the team, because in 29110, as you know, everyone has a role. So everyone has to learn how to play its role, and you learn how to interface and to work with different roles in the project. And this is exactly what is happening in industry. Okay, you maybe you will not be doing a project from beginning to the end, depending on the size of the industry, but you will have to play a role, and you will have to participate to one process. And most of the time, maybe you will be also participating to one or more of the activities in the technical process. So the 29110 is a good, or I would say an excellent training mechanism where you learn how to integrate the pieces of the knowledge that you got from the different courses, and you learn to do a project from when the customer knocks at the door with an idea until the time that you do the acceptance testing at the end with the customer. And you learn how to deal with the surprises, because all projects have surprises. I use the word surprise, but in other words, risks. Okay, there are positive risks and negative risks. Okay, but most of the time in software engineering, we are hit with negative risk, a negative surprise, and you have to react to that. So the 29110 provides you with a guide, like a cookbook, where you can follow each step. So once you have done one or two projects, maybe you have learned something, and then you can improve on the guide, okay, to make the guide more appropriate for the company where you're working. Because don't forget that the guide is generic. The guide is not imposing a tool. The guide is not imposing a programming language. The guide is not improving any methodology. The guide is not imposing a life cycle. Okay, so you have to select what is appropriate for you. And as you do different projects, you will be learning, and you'll be finding opportunities to improve for your company the guide. Okay, maybe, and again, it is a guide. Okay, so it means you can modify the guide. If there are terms like the statement of work, if you don't like this term, you can use another. If you prefer to use a list of needs, then you can change that in the guide, no problem. In other words, you can adapt the guide to the needs and the culture or the vocabulary used by your organization. So it is very powerful, okay, extremely powerful. As an example, I'm opening another parenthesis. I've been teaching 29110 in quality assurance in Thailand before the pandemic. And I went to Chiang Mai University, where I taught quality assurance in intensive mode over 3 weeks and a half. And I've been also teaching 29110. So in Thailand, they have 10 universities that are teaching 29110. And they have over 500 organizations that have been certified. So in other words, in the universities, they have educating software engineers with 29110. And when they get into industry, some of them will also get certified to 29110. So what the objective of the country is to improve the competitiveness of the VSEs and also to improve the competitiveness of the country as a whole. Because when you have hundreds and hundreds and hundreds of VSEs that are trained and certified to the 29110, they are more productive. Okay, they are producing quality software. They have customer that can trust them that the customer will get their product within the schedule and the budget. So it is a win-win-win-win situation. By that I mean the government has invested some money to help university in learning 29110. Government has put some money to help VSEs in learning about 29110. The government has put some money to help some VSE in getting the certification. The university have been training their students in using 29110, and when they graduate, they end up in university and in company, fully trained. And we, as editors of 29110, we're happy because we see that vicious circle, I would say virtuous circle, where when we produce a new guide, some university are teaching them, then government is helping VSEs to adopt it. VSE adopt them, they get certified, they get more competitive. So this is the name of the game. The reason for standard is to be more competitive. This is the bottom line of standard, to increase competitiveness. Okay, this is why 29110 has been established, and this is why many countries have adopted the standard as a national standard. Like Mexico, for Mexico, it is a national standard, as well as in Portugal, as in Brazil, as in Peru and other countries. So I don't know if I answered your question completely.
Yes, thank you very much, Professor.
Welcome.
And, yeah, there's no more questions, Dr. Gerardo.
Gracias, doctor Noé. Bueno, Adriel, ¿hay preguntas en Facebook? Adriel. Bueno, parece que no hay más. Josué.
No more question. No more question in Facebook, in YouTube. Thank you very much, Dr. Laporte.
Ok. Bueno, con eso termina la sección de preguntas. Pues no queda más que agradecer y voy a compartir pantalla más adelante. Professor Laporte, the virtual colloquium team thanks you your participation and contribution to our event. Now, I'm going to read the institutional recognition, and I'm going to share my screen. The National Technological of Mexico, through the National Center for Technological Research and Development, gives the present certificate of appreciation to Dr. Claude Laporte for giving the conference an overview of software quality assurance and the ISO 29110 series of standards and guides for very small entities, promoting universal access to knowledge with the framework of Virtual Colloquium 2022 of the TECNM CENIDET, Cuernavaca, Morelos, México, March 4th, 2022, and is signed by our director, Jessica Imelda Saavedra Benítez. Professor Laporte, please, can you give us a final reflection, final advice to our students, please?
I would say that the final advices are the one that are on the slides right now. Oh, do they see my slides, or am I out? Am I sharing my screen now? Not anymore?
No. Your final advice for our students.
Okay, so the final advice, as I said before, is you have to learn what your professors are teaching you, and you have to apply that knowledge. Okay, because just learning in your head, listening to your professor or looking at the slides is one thing. This is the easy part. Okay, the easy part is to getting the knowledge in your head. The tough part is doing it. So I urge you to transfer this knowledge in actual activities. Okay, put it in practice in your next project. And this is how you will see the difficulties and also the advantage of standards and things like that. Whatever practice, whatever things you learn in class, okay, you have to apply it. You have to apply it, and probably, maybe the first time it will not be perfect. Like, remember my chocolate cake analogy? Maybe the first time, but it will be, let's say, 90% good enough. And the second time, it might be 90%, 95% good enough. And the third time, you will be very happy. So I say, listen to what your professor are saying, put it in knowledge, and don't lose hope. Even if the first time you're not happy, okay, learn, okay? You have to learn, because life is like that, okay? Life is a bitch, okay? If it was easy, I would not be talking to you, okay? Because we would have already been doing this. It's not easy, and life is not easy. So roll your sleeves, okay, and work as a real engineer, okay? You have to, I would say, again, I'm not criticizing computer science, but I want to say move from developing a software code or some code component to developing a product with a product mindset, a product that will be used by real customers, will be used for many months, for many years, for many decades, and products that you want to develop with ideally no defects left when it gets to the customer. This is your objective as students when you get to industry.
Thank you very much, Professor Laporte. And with this, we finish this event. Thank you very much. Muchas gracias a todos. Con esto terminamos este evento, esta conferencia. Gracias al doctor Laporte. Sin duda, sus conocimientos son amplios y su experiencia vasta. Thank you, Professor Laporte, for your knowledge, expertise, and we are very, very happy for your contribution.
And thank you for the invitation. Thank you very much.
Thank you very much.
Bye-bye.
Gracias a todos. Cuídense mucho, por favor, y nos vemos el próximo viernes en la continuación de este coloquio virtual. Le tocará al Departamento de Ingeniería Electrónica. Gracias a todos.